Hello and welcome to Space Repo, your guide to the cosmos. Have you ever looked up at the night sky, filled with countless stars, and wondered how it will all end? It's a question that has captivated thinkers for centuries, a grand finale to the story of everything. Today, we embark on a journey to the very edge of time, exploring the most compelling theories about the universe's ultimate fate. We'll delve into the chilling silence of the Big Freeze, the violent unraveling of the Big Rip, and the cosmic collapse of the Big Crunch. So, buckle up as we peer into the final moments of existence itself. Our first potential destiny is known as the Big Freeze, or the heat death of the universe. This scenario is currently the frontrunner, supported by our best observations of the cosmos. It's not an explosive end, but a slow, creeping fade into eternal darkness and cold. It all begins with the relentless expansion of the universe. For billions of years, this expansion has been happening, and observations show it's not slowing down, it's accelerating, driven by a mysterious force we call dark energy. As space continues to stretch, galaxies will drift further and further apart. Imagine looking out from a future Earth. One by one, the distant galaxies that dot our night sky today will recede beyond our cosmic horizon, their light stretched so thin it can no longer reach us. The universe will become a much lonelier place. Our own local group of galaxies, including Andromeda, will merge into one colossal supergalaxy, but everything else will have vanished from view, leaving our new galactic home as an isolated island in an endless sea of expanding emptiness. Inside this solitary supergalaxy, the cycle of star birth will begin to wind down. The vast clouds of gas and dust needed to form new stars are a finite resource. Over trillions of years, they will be used up. The last stars will ignite, burning through their fuel, and then, one by one, they will die out. The universe will grow dimmer as the familiar stellar fires are extinguished, replaced by the stellar remnants they leave behind: white dwarfs, neutron stars, and black holes. The era of stars will come to an end. The sky will no longer be adorned with brilliant points of light, only the faint, fading glow of dying embers. The universe will enter a state known as the degenerate era. During this unimaginably long period, the only objects of note will be these stellar corpses. White dwarfs will slowly cool over trillions upon trillions of years, eventually becoming cold, dark spheres of matter called black dwarfs. Even these remnants are not eternal. According to some theories, over time scales so vast they defy human comprehension, even the protons that make up matter may decay. If this is true, then everything we know, planets, black dwarfs, all forms of matter, will eventually dissolve into a sea of fundamental particles and radiation. The only things left standing will be the black holes. They will be the last kings of a dark and silent cosmos, slowly consuming any stray matter that drifts too close. But even black holes are not forever. Stephen Hawking showed that black holes slowly evaporate through a process now known as Hawking radiation. It's an incredibly slow process for a supermassive black hole, taking longer than any timescale we've discussed so far. As they radiate away their mass, they will shrink, and the process will accelerate. In their final moments, they will vanish in a final, brilliant flash of energy, the last light in a universe that has long since forgotten what light is. After the last black hole evaporates, the universe will reach its final state, heat death. It will be a vast, empty, and uniform expanse, close to absolute zero temperature. Nothing will happen. Ever. The arrow of time will lose its meaning, as there is no change, no energy flow, and no complexity. Just a cold, dark, and eternal void. But what if the end isn't a slow fade, but a sudden, violent tear? This brings us to our second theory, the Big Rip. This scenario also involves dark energy, but a very different, more aggressive kind. In this model, dark energy is not a constant force but a phantom energy that grows stronger over time. As it grows, its repulsive force will become so powerful that it will overcome all other forces in the universe, including gravity. The beginning of the end in a Big Rip scenario would be signaled by the very fabric of spacetime being torn asunder. The acceleration of the universe's expansion would become frantic. At first, the effects would be seen on the largest scales. Clusters of galaxies, once bound by gravity, would be unable to hold themselves together and would fly apart. Then, about 60 million years before the final rip, the phantom energy would become strong enough to overwhelm the gravity holding individual galaxies together. Our own Milky Way would be dismantled, its stars flung into the expanding void. The chaos would escalate rapidly. A few months before the end, the force would be strong enough to rip apart star systems. planets would be torn from their orbits, sent careening into the darkness. Then, in the final minutes, the phantom energy would overcome the forces holding the stars and planets themselves together. The Earth would explode. The sun would be torn apart. In the last fractions of a second, the force would become unimaginably strong. It would be powerful enough to overcome the strong nuclear force that binds atomic nuclei together. Atoms themselves would be shredded into their constituent protons and neutrons. Finally, in the very last instant, the fabric of space-time itself would be ripped apart. The universe, and everything in it, would be annihilated, dissolving into an infinite scattering of fundamental particles. There would be no after. No void. Just the end of existence itself. While the Big Freeze and Big Rip are driven by expansion, our third theory proposes the opposite, the Big Crunch. This was once a leading contender, envisioning a cyclical universe of birth, death, and rebirth. In this scenario, the universe contains enough mass and energy for gravity to eventually overcome the expansion started by the Big Bang. Instead of expanding forever, the universe would slow down, halt, and then begin to contract. The cosmic clock would essentially run in reverse. Galaxies, instead of flying apart, would start rushing toward each other. The sky would fill with light again, not from new stars, but from the blue-shifted light of approaching galaxies. The temperature of the universe would begin to rise. As everything was squeezed into a smaller and smaller volume, the cosmic background radiation would heat up, eventually becoming hotter than the surfaces of stars. Stars would be cooked from the outside in. The universe would become a blazing furnace, too hot for life, too hot for planets, too hot for stars to even remain intact. They would dissolve into a plasma of their constituent particles. As the crunch accelerated, galaxies would merge, and then black holes would start to coalesce, forming a single, universe-sized supermassive black hole. In the final moments, all of space and time would collapse back into an infinitely hot, infinitely dense singularity, the same state from which the universe began in the Big Bang. What happens then? Some theories suggest that this singularity could bounce, triggering another Big Bang and creating a new universe in a perpetual cycle of death and rebirth. Our universe might be just one in an endless chain of universes. So which of these fates awaits us? A cold, eternal slumber? A violent, instantaneous tear? Or a fiery rebirth? The answer lies in the nature of dark energy, the most mysterious component of our cosmos. If dark energy is a cosmological constant, as our current observations suggest, then the Big Freeze seems to be our most likely destiny. A slow, quiet end in the far, far future. If dark energy is a phantom energy that grows stronger, then the Big Rip is a terrifying possibility. But if the density of the universe is greater than we think, or if dark energy somehow weakens and reverses, the Big Crunch could still be on the table. For now, the final chapter of the cosmos remains unwritten. We are living in a remarkable time, able to ask these questions and gather the clues that might one day provide an answer. The universe's end is a story that unfolds over eons, but by studying the stars, we can read its future pages. It's a humbling and awe-inspiring thought that our brief existence is part of such a grand and epic narrative. Thank you for joining us on this journey to the end of time. What do you think is the most likely end for our universe? Let us know in the comments below. And if you enjoyed this exploration of cosmic destinies, be sure to subscribe to Space Repo for more deep dives into the mysteries of our universe.